Here's a quick electronics hacking project to kick off the new year. I figured out how to cram an ESP8266 inside one of these Xbee repeaters, like you might find in a building-wide mesh sensor network. This is a way to power up your device while keeping it disguised, but don't do anything illegal, okay? This is just for fun, to create captive portal text games and scavenger hunts to play in apartment buildings, not to spew DAuth packets or anything else that could get you in trouble with the FCC. There's also a risk of electric shock here, so this isn't something to try without prior experience. I opened up one of these Xbee repeaters by gently squeezing across the seam in my vise until it popped apart. Inside, the Xbee radio is plugged into some headers, which makes it super easy to remove. I tried to figure out a way to fit the long Node MCU board inside, but it just wasn't happening, so I switched to the smaller Huzzah ESP8266, which fit just fine. The downside of this thing is that you need an FTDI cable to program it. I looked up the datasheet for the Xbee radio to identify the pins for power and ground, and then connected some wires with headers attached and tested to see if my network showed up when I carefully plugged it in. I tried keeping the original device functionality intact, and both radios do fit inside the enclosure, but there still isn't enough power to go around. But without the Xbee, the green light on the front doesn't come on, so I connected it directly to power through a small resistor. That way, when the whole thing is closed up, it still looks like it's on. It's supposed to flash, so maybe I should have connected it to a microcontroller pin instead. Anyway, this was a fun little reverse engineering challenge that I hope you enjoyed as well. Thanks for watching, and please subscribe to my channel for new videos each week about technology, crafts, and my life here in New York City. It's Becky. I recently moved from one Brooklyn apartment to another. It's my 10th in-town move in 13 years as a New York City resident, and brought to mind so many tips I'd like to share with you about apartment hunting and moving here I've learned along the way. Start researching listings early to get a sense for what you like and don't, but be open-minded about the specific location at first. Aggregator sites are great, and most can send you emails as new apartments matching your search criteria show up in their database. Make a list of your feature priorities, including low priority features, which could be used as trade-offs to achieve your high priority features. For instance, you may value a short commute time and large building amenities over square footage, or you may prefer a small building with a private yard and fewer neighbors. Your money will go further if you're willing to walk a few more blocks to the train or ride a few more stops. It's a common misconception that you have to live in Manhattan when you move to New York. I thought that when I moved here for college, and it couldn't be further from the truth. The transit network here runs 24/7 and rarely shuts down any of it without providing a viable alternative. You could use this nifty interactive transit time map on WNYC's website to see how long the subway commute is from anywhere in the city. And Google Maps does all the bus routes and cycling paths, so that's pretty cool for research too. If you're moving here from out of town, I recommend visiting for a full week for apartment hunting or assigning a friend you deeply trust to look at properties on your behalf. Real estate here moves really fast, so it's usually pointless to visit apartments more than 3 months before your move. Get your application materials together before you visit any properties. That way, if you like something, you can submit an application very quickly. The real estate market here is dominated by brokers. These folks match up landlords and tenants, and they charge somebody a fee, usually the tenant. You can work the total fee into the cost of a place you intend to stay for at least a few years. A broker's fee is negotiable, usually anywhere from 1 month's rent to 15% of the annual rent. If the listing is by a broker but there is no fee, then the landlord hired the broker to find a tenant. When you go to look at apartments, whether it's with a broker or with the owner, bring a notebook and take a note of the water pressure in the shower, how up to date the electrical panel looks, and the type of heat. It's common for heat and hot water to be included in the rent here, but the rule of thumb is that if you control your heat, you most likely directly pay for the utility that runs the heat. If you really like a place and are considering putting in an application, also take note of the noise level from the street or neighbors, preferably at multiple times a day. Check if the door buzzer works, is there a sink sprayer, and what type of internet is available at the address, and is there access to laundry in the building or nearby. Before submitting an application, use a research the building's address for its history of code violations and complaints. This can highlight a well-maintained building and also raise big red flags that you should not ignore. This last round, we saw an awesome loft, but it had a lot of complaints about the lack of timely repair of the elevator, which is a big deal for my niece. Another thing you can do is stake out the building's entrance in the daylight and approach current residents with something like, "Excuse me, I just looked at an apartment in your building and I was curious if there's anything you wish you knew before you moved in." Not everyone will be willing to talk to you, but those who do will provide a much clearer picture of what it's like to live there. Do the math to work out the total cost of each apartment you're considering, including utilities. Your gas bill might only be $20 a month if it's only your stove, or a lot more if it's also your water heater or heat. Likewise, your electricity cost will vary by the size and ceiling height of your place, should you choose to air condition it. Landlords are looking for tenants who can pass a background check with good credit and who can prove they earn 40 times the monthly rent as their yearly income. If that's you, you have some negotiating leverage about the start date of your lease if you want to optimize your overlap with your current place. I'm not a lawyer, but about the lease, just don't sign anything you don't understand or that seems counter to what's been presented to you about the apartment. If there's anything that needs to be fixed before you move in, make a record of it and ask to include its repair in your agreement. As if finding an apartment here isn't complicated enough, let's talk about moving. Start packing early and have multiple boxes going at once. Pack items so the whole box can be tipped on its side or upside down without breaking or spilling stuff everywhere. Label the box with its contents and use a colored sticker system along with a floor plan drawing of your place to identify its intended destination. My favorite packing materials are blank newsprint paper and that moving shrink wrap on a roll, which is probably terrible for the ocean. I'm so sorry. It's a lot more efficient to get rid of stuff before you move than after, so I always do a pretty big purge while packing. I list free stuff on Craigslist, or I look up how to throw them away.
I wanted to say proper goodbye to the boxes. This big pile, that's really great. Box full of boxes. It's what we call recycling night. And then we have to bundle these up, right?
I don't know about you, but I have a lot of stuff, and it's only okay to ask your friends to help you move if you don't have a lot of stuff, so I recommend hiring movers. They'll need an inventory of your stuff to provide you with a price quote. You should book a date 2 or 3 weeks in advance if your moving date's not flexible, because they get busy towards the end of the month. At the same time you book movers, check to see if your gas needs to be turned on at the new place, because that's an appointment you have to book in advance as well. When you get the keys, make copies and give a set to a friend in case you get locked out sometime in the future. Prepare for moving day by changing your address with the post office, your bank, your employer, and then call to transfer, cancel, or start service with the electric, gas, and telecom companies. Pick up some sports drinks for your moving crew and cash for tipping them after they're done. On moving day, keep a clipboard with the floor pan handy as well as a set of tools in case you need to take something apart to get it out of a small space. Wrap the furniture in moving blankets to protect it on the truck. Place your floor plan at the entry to make it easy to reference while you're carrying something heavy, and be available to answer any questions that might arise, but the labeling system really helps streamline the process. After you're done moving in, you have the fun challenge of hanging things on the walls. We mounted this pot rack to our kitchen brick wall using masonry anchors and drilling into the mortar only where possible. I also learned that we have metal studs, which meant I got to learn how to use snap toggles to mount my bike hanger. Instead of buying a new couch, we got a new slipcover from that website that has patterns for pretty much every IKEA sofa ever made. My final tip is to have a housewarming party, which will encourage you to get that last bit of unpacking done. Do you have any advice about moving where you're from? I'd love to hear about it in the comments. Thanks so much for watching. Please like and subscribe, and I'll see you in my next video.
Yay! Good job, Dad! He's like, I was overthinking it. Just had to go for it.
Hey, it's Becky. In this week's video, I want to share with you how I configured my new Panasonic GH5 camera. I've been a fan of the GH series for a long time, and finally bit the bullet to get a second camera to film alongside my GH4. The reason I like it so much, and the reason I think a lot of video creators like it so much, is that it's fast and easy to use and super versatile without sacrificing performance. I use mine in a hybrid fashion to create the videos here on my channel, as well as step-by-step photos in my tutorials. There are a few menu adjustments and other things I recommend to optimize the GH5 for these needs, so let's hop over to the voiceover.
The first thing that needs to happen is to get rid of the jangly strap attachments. The plastic retainer peels away from the triangular keychain piece, which I opened with my large talons. I saved these pieces in my camera bag in case I want to use the strap sometime later on. For some of the settings, it's important to see the picture, so I'll pop a lens on here. This is the kit lens 12 to 35mm, which I got with my GH4 a few years ago. With this GH5, I got the wide angle zoom kit lens, and that's what I'm currently filming with on the GH4, filming this shot. So far, this is familiar. The default setting is to shut off the LCD screen when the eye sensor is triggered, which can be super annoying if you don't know how to turn it off. Well, it's just this function 5 LVF button on the upper left, which toggles between LCD only, eyepiece viewer only, or that auto switching mode. One thing that's new about the GH5 menu is there's a new panel for your personal favorite menu items, stuff you access all the time. So I populated that list with the video record quality setting and the photo settings for image type and quality, aspect ratio, time-lapse animation, silent mode, and the self-timer. I usually like to shoot photos in RAW and JPEG, but will toggle just to JPEGs for creating time lapses. As for one-time settings I want to change, perhaps the most important is the video record format, which has to be changed to be able to shoot in 4K 60. I also like to turn on focus peaking, since I use manual focus a lot, and enabling the video priority display mainly changes what info is displayed at the top of the screen. There's a fun facial recognition feature that's used to enhance the autofocus in still photos, but I also like to use it as insurance to prove I own the camera. I include my contact info on the SD card, but those are easily formatted. This hides a photo of you inside the camera memory, which is unlikely to be deleted unless there's a factory reset. I don't like my tech making unnecessary indicator noises, so I just had to disable the beep. See, silent mode disables the noises, but also the mechanical shutter. I used it for time lapses. The rest of the time, I want to use the mechanical shutter to take photos, but I don't want to hear all the unnecessary beeping. I haven't had any experience with the dual card slot functions in order to have a preference, although I could imagine if I were recording something high stakes or in a weird location, I might elect to have the data written to both SD cards at once. Right now it just seems like a capacity luxury, and in my studio I have little need for in-camera backups. Updating the firmware is kind of a pain, honestly. Not actually executing the update, but getting to the download file on the Panasonic website, which involved a bit of a maze of model selection, serial numbers, and end-user license agreements. If it weren't for the new tethering feature, I probably wouldn't have bothered. But the ability to control and shoot from the computer is pretty neat, and something other cameras have done for some time already. It's convenient that everything's saved to both places too. I'm looking forward to using my GH5 alongside my GH4 for upcoming videos.
Thanks so much for watching. I release new videos every week about technology, crafts, and my life here in New York City. Please subscribe to catch the next one, and follow me on social media for a peek at what I'm up to. See you next time. Hey, it's Becky. I promised I'd update my YouTube subscriber counter project when I hit 10,000, so that's what we're doing today. If you don't remember version 1, here's the recap. The circuit uses an ESP8266 microcontroller to fetch the live subscriber count, then displays the number on a 7-segment display. The whole thing's inside a shadow box made to resemble a play button award. This time around, I'm using the standard backpack kit for 2 of these displays, and I soldered them up according to the official assembly instructions. The backpacks make it super easy to communicate with the displays using only 2 pins over to I2C. The way the microcontroller can talk to more than one display is to change its I2C address by bridging one or more of these address pads on the back. I'm using a Node MCU board this time, but any ESP8266 boards with the I2C pins exposed will work just fine. In my case, that's D1 and D2. I always build a breadboard prototype for projects before attempting to solder the final version, which gives me a chance to make any adjustments while I work on the code. To write out the number across both displays, first I'll set them up with their corresponding addresses and initialize them in the setup. Then, when it comes time to display the subscriber count, I'll split it up into two variables. Divide the count by 10,000 to get the digits for the left display, and then take the remainder, that's what this modulo does, divide by and then take the remainder of 10,000 to get the digits for the right display. If the left display has something to display and the second number is under 1,000 or 100 or 10, we need to add some zeros to link the digits with the left-hand display. The network components of this sketch use Brian Lau's YouTube API library for Arduino. You just supply your Google API key, YouTube channel ID, and your Wi-Fi credentials. I've also published a version of this sketch that uses Wi-Fi Manager, so you can change the network without reprogramming the device at Brian's suggestion. I put together the final circuit using a Perma Proto, but because my frame is only 5x7, a full-size one wouldn't fit. I should have gotten a bigger size. I managed to put everything on the half-size breadboard, but I wouldn't recommend you follow this layout exactly, since I sort of hacked away some of the pins on the Node MCU and cut traces to others on the back of the Perma Proto. I made a second display for the rest of my social trackers, positioned things a bit differently, which I think worked out a little better. Anyway, I scaled up my template and cut it out using this other piece to help with display positioning. Everything just barely fits into the shadow box with a little scrap cardboard as compression padding to get the display pressed up against the glass. You can find the printable template, code, and full instructions for this project at the link in the description below. Thanks so much for watching. I release new videos every week about technology, crafts, and my life here in New York City. Please subscribe to catch the next one and follow me on social media for a peek at what I'm up to. See you next time. Hey, what's going on, guys? Welcome back to my studio and my channel. Last week, I published this video about this YouTube subscriber counter button. A lot of you asked me questions about this other counter I made to go along with it that tracks my Twitter and Instagram and Instructables followers. So today I'm posting a follow-up video about how to make that tracker. Just like last time, I'm using a 5x7-inch shadow box to build the circuit inside. And then I'm using a graphic printout that I made using the logos for the various sites I want to track face down inside, and I'll press the 7-segment displays up against the back of the paper so they shine through without being blurry. Unlike my YouTube subscriber counter, this circuit is a little more modular with header wires coming off of the back of the 7-segment displays as they plug into wires next to the microcontroller board, which is on its own small Perma Proto. And that's a Node MCU, in case you're curious. All the 7-segment displays plug into the I2C bus, so they're all actually in parallel with each other. The data and clock lines are, that is. And the way that the microcontroller addresses each one is by telling it apart based on how the address tabs are soldered at the back. And we'll go through that more in the code. So here's the Arduino sketch for the multi-social tracker. It's basically a bunch of Brian Lau's different API library sample codes mashed up together into one sketch that can drive a bunch of 7-segment displays. So definitely check out his various libraries on his GitHub and his YouTube channel and his Instructables. Really, really awesome and helpful, and makes projects like this easy for someone like me who doesn't have all of that web coding experience. So first we'll include all of those libraries and their dependencies, the Arduino JSON library and the JSON streaming parser, as well as the LED backpack and GFX libraries needed for the 7-segment displays. Then including the stuff for the Wi-Fi, and then here's a custom section you would change to be your network name and password, sign on to your Wi-Fi network. And then this is the Twitter authentication bearer token. I generated this as per Brian's instructions using my API key and my API key secret and the command line. And then, but the other two, the Instructables and the Instagram, don't require you to sign in to get any of the information. Then we create, one of them needs a secure, two of them need a secure client, and the other one can be insecure. So we'll just set up the Wi-Fi clients there. And then this is going to be the number of minutes in between checks. Then here's the configurable section for the username. So your Twitter username, Instructables username, and Instagram username. And then just like in my YouTube subscriber counter, sketch, I wanted to set up multiple 7-segment displays at once, but in this case there's 6 of them instead of just 2. And I don't have 6 in my circuit. I actually only have 4 inside my circuit. So I'm only popular enough on Twitter to need 2. And then the other 2, although I only am using a display for the low digits of each and have those displays soldered to reflect these different addresses here, I actually omitted the high digit displays from the Instructables and the Instagram rows, which lowers the cost of the project. So I don't have enough followers to need that second display, but the code supports it. So should there be a day, I can just paste another display inside there. And then for those of you who are fortunate enough to be more popular on these different networks, this code will already work. Anyway, okay, so in the setup, I'm just using, initializing the displays all at once using a for loop, setting up the Wi-Fi stuff, like logging into the Twitter situation. And then in the loop, it just calls each one of these get stats functions with a delay in between, which I found was pretty critical to making them all play nice with each other. And each of these functions is just borrowed from the example code in Brian's libraries to get the different stats. And I've added in that same little section of code I explained in the last video for splitting up the numbers if it's over 10,000 and writing the lower digits to the right-hand display and the higher digits to the left-hand display, and then padding it with zeros, which is based on that Death Clock project that Phil B wrote on the Adafruit learning system, wrote that code. So that's really helpful there, and I just added it to each one of these functions that gets the stats, and then in the loop, each one of those functions just is called and then writes to the display every minute. When I made this counter, it's just one piece of printer paper and the display is taped to the back, but it's kind of wedged in the side, so support it. Here it was taping the displays directly to the paper and they were making it sag a little bit, so I used a thicker paper, 2 sheets of it actually, and you can see the difference in light emission. So I'm going to try to reconfigure this with thin paper in the front, thicker paper in the back, see if I can get it to be a little bit more even. That's it for this project, everybody. Thank you so much for watching and for subscribing to my channel and to my other social accounts so you can see what I'm up to. I put out new videos here every single week about crafts, technology, and my life here in New York City. See you next time. Hey everybody, it's Becky. Welcome back to my studio and my channel. Today I am kicking off a video series about a new piece of furniture my boyfriend and I are building. It's a plywood storage wall. Let's go. The structure is pretty simple. It's a box with uprights and nailers to attach to the wall only, and then shelves between the uprights on top of the nailers. And then we use pocket hole joinery to hold most of the things together with a little extra bracing here and there. We're also going to put a set of cabinet doors on to keep everything contained at the end. We started by measuring and taping the area in the dining room where we were going to build this thing to kind of give us an idea of how it will break up our space, and we even decided to make it a little bit shorter in the end because we didn't like the tight space by the kitchen counter. After that, we could dimension out all of our plywood and make the cut list and start cutting. Now, we don't have a table saw or like a truck to easily get us to the nearest table saw with our plywood, so we're just making all of these cuts inside the house using the circular saw and our portable sawhorses. I used a website to optimize our cut lists to minimize waste, but that meant I was also cutting uprights at the same time as doors, and so I was labeling pieces and setting them aside before I ever had enough pieces to actually start putting up the nailers. When it came time to start installing, I started on the corner where it had to be flush with an existing corner, because no one's going to notice if it's off on the other end in the middle of the wall. This wall is made out of several layers of drywall with metal studs behind it, so these snap toggles were perfect for going all the way through, toggling open, and then sandwiching down to really provide a secure fit, and it's in studs in as many places as possible. I don't think this thing is going anywhere. The first shelf is a special one because it's for the cat to hang out. Mr. Jazzman likes to go up high. The new place doesn't have that many up high places, so we thought we'd make sure he has his own little cubby. So I used my jigsaw to cut out a hole that he could climb through in the shelf before sanding everything down and installing it. For now, he's just using boxes to get up there, but we're gonna make him a special cat ramp, don't you worry. Oh, okay, a little bit of a tight fit. Still working on it. I also used the jigsaw to cut out a shape at the bottom of each upright to accommodate for the baseboard molding.
So we got to building, and I've been cutting away, and everything's been really fun with the power tools. But then my boyfriend broke his ankle in January, and so that's been a little tough because I've gotten limited knee stuff, so I can't really climb ladders. The project was stalled for a little bit. But then last weekend, a friend of ours came over and helped us with some ladder stuff, which got us to where we are right now. And now my boyfriend's ankle's feeling a little bit better. We think we can do a little bit more ladder work to get things going. So remaining to do is more cutting and sanding of parts, of course, installing those parts, making a ramp for the cat, and also doors, painting, funnel finishing, all that. So thank you so much for watching. It might be a few weeks before I revisit this project, but please join me next time. Subscribe to my channel if you haven't already. Put out new videos every week about crafts, technology, and my life here in New York City. Hi folks, it's Becky. Welcome back. Today's a quick sidebar to my plywood storage wall project that's all about 3D printing. Now, I got one of those Kreg pocket hole jigs to create all the pocket holes for my plywood project, and I also have the Festool dust collection system, and the dust shroud that comes with the Kreg doesn't fit. So I had been using some tape to tape it together every time I use it, but that's no fun. So I thought this week, I'll just make a quick coupler. I'll use Tinkercad and I'll work up 2 cylinders that are each the right size and then make a piece to join them together. But you know, I opened up a blank file and I thought like, there's enough people out there that probably have these 2 systems and a 3D printer that let me just check and see if it exists already. And here's like the place we are with 3D printing these days, and Arduino projects for that matter. Like if you have a cool idea that you want to make, just check and see if someone's done it first, not to discourage you, but rather to like build on their design. So I looked for a coupler and I found something even better. Thingiverse user Tooltutor actually modeled the entire part of the dust shroud and with an outlet that fits the diameter of the Festool hose. So thanks Tooltutor, that's awesome. It's way better than what I would have done, which is just make a coupler that goes between the original dust extractor. The only gotchas were I needed to scale it up because the units were in inches and my Autodesk Print Studio software uses millimeters, so the conversion factor is 25.4 times. So in percent, that would be 100% times 25.4, which is 2,540% to get it back up to the right scale. And sure enough, when I printed it out, it printed perfectly. I also read from one of the other makers of the part on Thingiverse that it came out better when you print it upright, just against the original modeler's suggestion for which is for print speed, to print down like this. So I printed it upright with supports on my Rep 2 and it came out just fabulous. I couldn't be happier, except that I didn't get to share the making process of something new with you guys, but that's okay because it does exactly what it's supposed to do and it works awesome. In case you're wondering what my shirt says. I got it at Maker Faire Bay Area, I don't know, 2008, 2009? If you know of anyone with the Festool dust extractor and the Kreg jig, please tag them on social media with this video so that they can find the part for themselves. And thank you so much for watching. I'll be back again next week with a new video about crafts, technology, my life here in New York City. I'd love it if you would subscribe. Take care, see you next time. Hi everybody, welcome back to my channel and to my photo setup. Today I'm going to show you how I built a foot pedal shutter remote for my GH5 camera. See, I do a lot of tabletop photography like this, and I usually need to show off some kind of small electronics or craft project where both of my hands need to be in frame. And to do that and focus and then do the self-timer, it takes a lot of time. So I just looked up the circuit design for the commercially available shutter remote with a button on it. I made a shutter remote for my GH4 out of a commercially available shutter remote, and I just added wires to it, but it was expensive, and then I added on to it. It was kind of bulky. So this is a more streamlined approach that just has the inline resistors between the proper 2.5mm 4-pole like micro audio jack that's here, and this any foot pedal switch you find online should work just fine. Let's get started. I cut my 4-pole 2.5mm plug from an adapter I ordered online and proceeded to remove a few inches of the outer sheathing with wire strippers. I bundled up the loose copper sheathing wires and stripped a small amount of sheathing off of each interior wire. Then I used my multimeter set to continuity testing mode, you know, where it beeps when there's electrical contact between the probes, to figure out which wires are connected to the shaft and the first ring. Then I cut off the other wires since they won't be used. In my case, the relevant wires are the sheathing and the black wire, so I tinned them with solder and added solid core wires to make it easy to plug into a breadboard. That's where I tested out resistor combos to add up to the values from the diagram, which is how the math works out when you put them in series. Turns out there's some margin in the values, so it doesn't have to be exact. Use what you have. Here in this Tinkercad circuit simulation, you can see what I mean a bit more clearly. The circuit on the left is the ideal configuration, and these others are the ones I tested with the camera and physical breadboard. The basic idea is that the shutter pin is held high at about 40 kiloohms, and the switch drops the resistance across the poles to about 2.2 kiloohms. You can add an intermediary button for the half-press focus functionality, which I skipped because it's not needed for my application. Once I had settled on a combo of resistors in prototype form, I set about creating the cable. Some care and attention to detail is necessary here, as well as a good set of helping hands to line everything up so as to create the smoothest, strongest transition possible. Don't forget to add heat shrink tubing whenever possible. I should have written down my switch findings immediately after using the multimeter, but I didn't, and it made me mix up which switch wires to use, so that's why there's a change of appearance here. After I fixed that error and tested it again, I could heat up the final piece of shrink tubing. What I love about this project is that it will improve the quality of the time I spend behind the camera, but itself was also a pleasure and relative breeze to make. Great effort to satisfaction ratio on this one. Thanks so much for joining me today. I hope you learned something. You know, you don't have to put a foot pedal on this thing. You could also use just this camera activation portion to incorporate into your microcontroller project. Maybe do some high-speed photography, some like motion-activated photography. Anyway, I'd love to hear how you're going to use it in the comments below. Thank you so much for watching. If you're new around here, take a look around. Consider subscribing. I put out new videos just about every week about crafts, technology, and my life here in New York City. See you next time. Welcome back to my studio, and a huge hello if it's your first time here. I'm Becky. Today we're building a circuit to measure the precise angle of a knife blade while it's being sharpened. This is a collaboration with one of my favorite YouTubers, Alex French Guy Cooking, who's always making and sharing inspiration around food.
Hey guys, what's up? It's Alex.
When Alex first approached me with this idea, my first thought was to try using an accelerometer to detect the angle. So I pulled out my Circuit Playground board, which not only has a LIS 3DH accelerometer, but also some LEDs I could use to create a crude feedback interface for the preferred angle. I taped a magnet to the back, kept it plugged in over USB, and then stuck it to the side of the blade. For a 10-minute prototype, it actually worked okay. But practically speaking, there's a problem with precision here, since during the actual sharpening, the knife blade is moving from side to side on a different axis than we're trying to measure, which throws off the reading. The proper term for what we're trying to measure is dead reckoning, or absolute orientation, and it requires a combination of many sensors to achieve, as well as processing power and sophisticated code to make any sense of the data in real time. The BNO055 does all that with an internal accelerometer, magnetometer, and gyroscope, as well as an ARM Cortex-M0 processor that's doing all the sensor fusion and sending out values you can actually use, even if you don't have a PhD in sensor modeling. The fancy math it does is what makes it different than most other 9DOF sensors you can find, and it makes it a bit pricier too. But this is one case where I'm willing to pony up in order to avoid writing my own Kalman filter. Knowing Alex was interested in using a mobile device for feedback and potential further development of this project, I hooked up the sensor to a small Bluetooth microcontroller board, the Adafruit Feather Bluefruit 32U4. I used the sensor library's sample Arduino code to test out the angle reporting over the serial monitor, and then set about soldering together a smaller version for attaching to the knife blade. To keep the sensor parallel to the blade, I mounted it on the underside of the microcontroller board and used thick neodymium magnets as standoffs. Add a little tape and a small battery, and this prototype is ready to rock. I used the Bluefruit LE Connect app for Android or iOS to receive the UART data from the microcontroller. The code I wrote, which is barely modified from the sample, prints the relevant knife angle out on the mobile device. Cool. The last feature to address before we can really get sharpening is that of waterproofing. The enclosure should be splash resistant since the blade is rinsed often while sharpening. The quickest thing to do is to stick the circuit in a plastic bag or two. It doesn't have to be pretty. Just to earn that extra gold star, I made a simple translucent 3D printed enclosure using Tinkercad. It has an O-ring on the lid to keep the water out. When it's dry, you can take out the stopper and charge the battery over USB. Oh, and I know somebody's gonna grill me about 3D printing waterproof enclosures, how you should use something that can be chemically smooth like ABS, or something super high precision like nylon to make sure there's no holes. But for me and this pretty tame application, it worked just fine at 100% infill in regular PLA. But I linked a resource on that for y'all to check out below. So I got the stone Alex recommended in his first sharpening video, and I'm gonna give this a try. The idea here is to create something that helps you learn the muscle memory of sharpening, so you actually get better at it over time. Imagine that, an electronics device that is training itself out of usefulness. To develop the app side of this further, I would take a look at something called Cordova, which makes it easy to build your own app using HTML and JavaScript, as I've seen Todd Treese do with his very similar project for coaching your hand sawing angle. If you'd rather skip Bluetooth altogether, a simpler board could provide visual feedback using an LED or two, like a regular Feather 32U4. Thank you so much for watching. If you came here from Alex's channel, welcome. I've created a special playlist of my videos that I think you would also enjoy. The link to that and the full step-by-step tutorial for this build on Instructables are in the description below. Please give this video a thumbs up and don't forget to subscribe if you haven't already. I release new videos just about every week about technology, crafts, and my life here in New York City. See you next time. Hi everybody, it's Becky. We're in my kitchen today so we can make some glowing gummy candies that look like LEDs. To make this simple gummy candy recipe, we need some plain gelatin, a box of sweetened jelly dessert mix, as well as cold water. I like to add ascorbic acid for the tartness, and the special ingredient that makes the candies glow under black light is vitamin B2 powder. You'll also need some candy syringes and a food-safe mold to make these candies, which you can buy in all kinds of fun shapes like bears and hearts and stars and stuff, but not in the shape I wanted, so I made my own mold. Flashback to a few years ago when I first made LED gummies as one of my Adafruit projects. I used foam core, hot glue, and a few packs of 10mm LEDs to construct a mold form. I had ordered food-safe silicone online, which comes in 2 parts, measured it by weight, and mixed the 2 parts very, very thoroughly before pouring it into my mold form. My colleague Paige wrote an amazing free online Instructables class on mold making and casting if you want to learn more about how to do those things properly. I'll put a link down below. After removing the mold from the form, the instructions for my food-safe silicone said to bake it at a low temperature for several hours and then give it a regular hand wash before using. This one goes in the freezer for now. When I made this project the first time, I made a major oversight in not lighting up the candies themselves, so today I'm here to fix that. I knew about the B2 trick from the Kryptonite candy project video I had made from Britliv's Instructable even a few years before the LED gummies, but I just plumb forgot to try it out. I've had this ever since then. Additionally, today we're going to take things one step further and experiment with embedding tiny surface mount LEDs inside the gummies as well. Those won't be for eating, though. Okay, let's get started with our first batch of candies. Oh wait, one more thing. The LED candies need LED legs or they just won't look right. Way back when, Matt Griffin modeled for me this tiny little toothpick-like piece of 3D printed plastic using Tinkercad. So I printed out a fresh batch in silver PLA filament. 16 of them print in 15 minutes, so it's easy to churn out a whole bunch. Okay, back to the candy. Start with a 1/3 cup of cold water in a heat-resistant mixing vessel. Slowly sprinkle in 3 packets of plain gelatin as you stir to keep it free of lumps. Let the mixture rest on the counter for 10 minutes or so the water and gelatin can dissolve completely. While you wait, you can set up a pan of warm water on the stove to simmer. After 10 minutes, move your mixing vessel into the simmering pan to melt the gelatin down. Don't bother stirring it now, you'll only introduce unwanted air into the mix. Once it's completely melted, add in the packet of jelly dessert mix slowly and stir even more slowly to reduce the amount of added air, which can make the candy cloudy. Turn off the heat and then add the ascorbic acid and vitamin B2 and stir to dissolve. Put the mixture in the fridge for about 5 minutes to get it to cool down and also separate into layers. As the air leaves the mixture, it leaves super clear candy at the bottom and cloudier candy up top. So if you want like clear lens LEDs or diffused lens LEDs. The gummy stuff is kind of difficult to clean, so I set up my station with parchment to catch any drips and my 3D printed LED legs nearby. While that one's cooling, I'm gonna prep another batch. The B2 looks a little granular in the fridge, so I'm gonna try with this batch, I'm gonna try adding the B2 powder to this step, and then I'll cook it with the gelatin and see if that'll help it dissolve a little better. After the candy has cooled a little, use the candy syringe to pull up the super clear stuff from the bottom, then squeeze it into each cavity of the mold. There's a sweet spot as the candy cools that will make the placement of the LED legs easy, but also with holding power. Don't expect a 100% yield on these. Some will be much less perfect than others. Allow the candies to cool, optionally chilling them down to speed up the process. Then flex the molds to take them out. For this batch, I want to make yellow LEDs, but I don't have any yellow Jello, so I'm kind of just making my own out of a 1/4 cup of sugar and another packet of gelatin here. And then when this melted gelatin that has the B2 in it comes off the heat, I'll add in a couple drops of this yellow food coloring, as well as the ascorbic acid for that Sour Patch-like tartness. Shine a little UV light on the candies to watch them glow. To take this concept further, I pulled out my surface mount LEDs and I soldered some wires onto them, which I then wound around the 3D printed legs before inserting in the candies. Remember, don't eat these, they have solder on them. Even if it's lead free, that stuff is no good. Okay, let's try out the ones with the electronics in them. Wow, that's great. Oh, it's so pretty. Okay, let's try a green one. Yeah, okay, not half bad. It depends on where it's placed inside. I'd like to see it like a little lower down maybe. Let's see if there's one here that's a little lower. Super cool. The red one? The red ones didn't come out so evenly, or so straight. Okay, yeah. Thanks so much for watching, folks. If you liked this project, please give this video a thumbs up, check out the tutorial and the link in the description, and subscribe to my channel if you haven't already. I release new videos just about every week about DIY technology, crafts, and my life here in New York City. See you next time. Welcome back to my studio. It's Becky. Today's video is part 2 of my storage cabinet series, where we'll be finishing up the main structure and hanging the doors. We left off last time having made the cut plans and installed the first nailers and uprights. From there, we continued to cut, sand, and label all the plywood parts, including as many shelves as we could fit on the remaining scraps, too. All the nailers and shelves needed pocket holes drilled, and I used my new 3D printed jig to vacuum up the chips. Together, Smokey and I installed the remaining uprights, nailers, and primary shelves. Since we're renting, we didn't use glue to join any of the perpendicular pieces. That way it can be disassembled easily if that becomes needed. We did glue and brad nail in some shelf supports on the uprights to provide more structure there, but the shelves just rest on them in addition to having those pocket hole screws. After the main structure was complete, we finished the interior with 3 coats of Minwax polyacrylic. It dries quickly with a durable finish, and the fumes aren't nearly as bad as the high-test stuff. The next day, we started to hang the doors, which are just solid pieces of the same Pure Bond plywood. We're using 2 different hinge styles, depending on where the door is and which way it's supposed to open. We changed our mind about the cabinet closest to the kitchen and ended up 1 set short on the wraparound hinges. If I could do it again, I'd have ordered a 2nd set of each kind of hinge, since now the one I need is on back order. We wanted the center rows of doors to remain wood tone, so those got a few coats of polyacrylic as well. We'll paint the rest of the doors soon, as well as install the cat access way to his special perch. I'm working on some plans for this build, including a 3D model in Tinkercad, a cut list, and all that, so stick around my channel to catch those with the final installment coming soon, just as soon as our backorder set of hinges arrives. In the meantime, we've been able to move stuff into the cabinets, including all of our books, which is a huge relief to the last remaining tasks for settling into our new Brooklyn apartment. Thanks for watching. If you're subscribed, you know I publish new videos just about every week about DIY projects, like my camera shutter foot switch or my dining room chandelier. Should I do a live stream this month? I'd love to hear your feedback about that and this project in the comments.
See you next time. Today I'm going to make a leather wallet with custom etched detailing. My first step was to create a paper pattern, so I drew it out to fit some cash and cards. It consists of 2 main body pieces and 2 card pocket pieces. The outer layer has to be slightly longer than the inner piece in order to fold up together evenly. I used a thick ruler and sharp rotary cutter to divvy up my leather, but you could also use a utility knife or a pair of shears. I had this piece of leather left over from last summer's solar engraving project, and luckily my pattern fit around the engraving really well. You can check out my video about that process by clicking the card in the corner or the link in the description, and it's part of my free solar class on Instructables. While you're over there, check out Michaela's leatherworking class, which is how I learned all the skills for this project. You could also laser engrave your leather or use a wood burning tool or hot metal stamp to scorch in a design. I used a skiver to shave down the thickness around the edges of the pieces to be layered together so they'd be easier to sew. Then I used some double stick tape to attach the card pockets to the interior body piece. I had bought a simple starter kit for leatherworking, which came with both of these groove cutters, though I'm pretty sure I didn't need to use both of them on the same line here. The groove creates a line that's easy to follow along with the stitching chisel to create holes for sewing. I cut 2 long lengths of waxed thread and used 2 needles at a time to saddle stitch along the open edges of the wallet first. I don't have a stitching pony, so I just used my helping hands tool to hold the work in place. If your needle is stubborn or your hands get tired, you can use a pair of pliers to pull on the needle, though I don't recommend using it for pushing or you might stab yourself real bad. Then I taped and made holes in the short ends. I picked up the same long strings to sew down the sides and across the bottom of the wallet, meeting in the middle. I doubled up on the stitches that span the start of the card pockets for reinforcement and pulled the strings to the inside of the wallet for hiding a square knot. A bit of E6000 adhesive secures the knots in place, and I let it dry overnight before trimming the tails. To form the thick leather to keep the fold, I added some cards and cash and then clamped the wallet in between some cardboard with big binder clips. This is one of my first leatherworking projects, and I really enjoyed the process and look forward to making more projects with leather in the future. Let me know what you'd like to see in the comments below. If you like this project, please give this video a thumbs up and subscribe to catch more DIY projects just about every week, from crafts to technology and my life here in New York City. Thanks for watching, and I'll see you next time. Welcome back! In this week's video, I'm making a Tumor Louver hat for Simone Getch with my friend Leslie Birch.
Hey, and it was inspired by Simone herself when she said that she has a tumor the size of a golf ball.
The hat makes an emphatic effort to eject the tumor using a 3D printed scissor snake propelled by a servo motor and small microcontroller. I found this part by Thingiverse user Richard Swicka and loaded it into Tinkercad, where I replaced the finger holds with mountable tabs and the grabbers with little holes for attaching the plastic golf ball. The base piece holds the servo motor and has mounting holes for sewing onto the hat. We prototyped the circuit with an Arduino Uno and servo motor to see how much of the motion range we wanted to use and the optimal position of the servo's horn. Then we miniaturized the circuit by switching to a tiny Trinket microcontroller and soldered the power, ground, and signal wires, and also the battery power and ground wires. We're using a 3 AAA pack to add up to 4.5 volts. We got this silly derby hat online and dressed it up with some additional fabric to bring together the color scheme and add more volume behind which to attach the circuit scissor snake assembly. The battery and microcontroller live inside the band of the hat.
CPU insert.
Simone, we love you.
You've got this.
And we've
All got you.
It's time to say goodbye to Brian. Ready?
Yeah.
Bye, Brian!
Bye!
Welcome back. This week I'm building a simple wobbler bot inside a loaf of bread. Let's get started. This simple bot design is by my friend and colleague Randy Serafan. It involves modifying two continuous rotation servo motors to bypass the control boards, effectively making them into just gear motors, which are powered by a simple battery pack. The wheels aren't round, which is what gives the wobbling effect. The circuit can be attached inside any enclosure you want, like a small Tupperware in his case, or a Baguette in mine. See, there's this interactive art show coming up this weekend at my hackerspace, NYC Resistor, and the theme this year is self-driving carbs. So Randy proposed bread bots, and I hopped on board to build a few based on his excellent SimpleBot Instructables. If you're near NYC this weekend, come check out the show. I'll put a link in the description. I broke the first baguette I tried this with and learned a few things from the attempt. It's important to let the bread dry out for a day or two before trying to put in the electronics, but there is a sweet spot, and if you wait too long, the bread will be too brittle. I used 5-minute epoxy for most of the glue ups in this project. I ran out at the end and used some hot glue to attach the battery door cover. Also, here's a fun tip. Did you know you can use canned air to dry hot glue quickly? It's because the air coming out of pressure is cold. I learned that from my friend Gareth's new book. I'll link that below too. After the glue dries and the bread is mostly dry, I put on a few coats of shellac to seal up the bread. This is what I found was recommended when I looked online at tutorials for preserving bread for display. Shellac is a pretty hard finish, but who knows how long this thing is going to hold up rolling around all night at a party. The other robot I made is this plastic plate vibrobot. I was thinking of putting more shellac baked goods on it. Do you have any suggestions? I'd love to hear them in the comments. Thanks for watching, and please give this video a thumbs up if you liked it. I release new videos just about every week about technology, crafts, and my life here in New York City. Please subscribe if you haven't already, and follow me on my other social media for a sneak peek at what's to come.
Welcome back. It's Becky. Today I'm building a shelf underneath my desk here to store and protect all of my external hard drives. Let's get started.
Take a peek behind my computer and you'll find a stack of external hard drives and a mess of cables. I keep a piece of fabric in front of this area to help keep dust out, but it's far from perfect and takes up a lot of horizontal desk space. My goal is to free up this space while creating a safe home for my drives, where they could get fresh air without clogging up their fans with sawdust or anything else. The design I came up with consists of 4 pieces. The top is a bit longer in one dimension to make tabs for mounting it to the underside of my desk, and the front and back of the box are left open to allow airflow. I'll install some filter material over these openings later. I measured my drives and established some interior dimensions, then worked out a simple cut list. I'm using some leftover 3/4 inch plywood from my storage wall project, so I made sure to add 1.5 inches to the desired width of the bottom shelf. I'm using my circular saw to make all the cuts, and I'm starting to get pretty good at cutting straight lines, but you'd get an overall more accurate result if you use a table saw. I'm using simple pocket hole joinery to attach the pieces together. So I drilled holes with my pocket hole jig in the 2 side panels and started gluing and screwing the pieces together. But here's where I discovered my mistake. See, in my original sketch, I had the shelf tall and skinny, just like the stack behind my computer, and this left plenty of space to fit the screw gun in there for the pocket hole screws. As the design evolved, I landed on a more squat design to fit multiple smaller stacks of drives, and the clearance vanished without a second thought.
Rookie mistake.
I should have made the sides longer and the shelf shorter, so that pocket holes and screws would be going horizontally into the side panels. My quick fix, since that part was already together, was to add some more pocket holes on the outside of the as of yet unattached top edge of the side panels. Nobody's going to see this part of it, or even the whole shelf at all once it's done, really. After fixing that hiccup and letting the glue dry, I sanded the whole thing down to 120 grit. If you wanted a more refined look here, you could go over the corners with a round over bit in your router before sanding. After sanding, I applied 2 coats of polyacrylic to seal up the plywood. This project was very fast and loose. I think all in all it took me about 3 hours to put it together, so it was not a surprise I forgot a step before finishing. Since I want to cover the shelf openings with filter material, I need a hole for the cords to exit the box without interfering with the planer filter material. So I used a big Forstner bit to drill a hole in the bottom shelf, then connected it to the edge with a handsaw. I got this filter material online, and I'll put a link to it in the description. I don't care so much about whether it's activated charcoal or not, but the dense mesh material will physically keep out the dust nicely, and I like the black color. You could probably substitute lots of different materials here to achieve the same result. I cut 2 pieces to fit the shelf's opening, and stapled the front one in place. Then I used some sticky Velcro, just the hook side, all around the interior of the back opening, which happens to stick to the filter material quite nicely. To install the shelf under my desk, I drilled 3 holes in each of the mounting tabs and drove in some wood screws that were short enough not to poke all the way through my desktop, which is one of those beach butcher block tables from IKEA. Then I went about moving my drives, one at a time to make sure I kept the right power supply with each one, from my desk into the shelf. I had room enough for all the AC adapters too, but my power strip here is a bit too long. I'll switch it out for a shorter one at some point. What's cool about this arrangement is there are no cords or power bricks on the floor at all over here.
This isn't the most glamorous project. In fact, I pretty much forgot that I did it as soon as I sat down at my desk, but it is really useful. It cleared up a bunch of desk space, and I also feel more confident doing woodworking in this room now that I know that the air intakes for the hard drive fans are protected. So let me know what you'd build with these techniques in the comments below. Can't wait to see you on my next build. Subscribe if you haven't already, and follow me on social media to get a sneak peek at what's to come. See you next time.
LEDs are intense point sources of light. To spread out or intentionally give shape to that light requires a translucent material and a lot of experimentation. This is a list of my LED diffusion ideas, gleaned from my past projects and some new experimentation too, so stick around for that. You'll find a link in the description to the companion Instructable for this video, full of links to tutorials containing these techniques as well as where to find the materials I mentioned. We'll start out with an easy one. Just use a box, either homemade or easily found shadow box frame, for example, and line the inside with plain printer paper. In my Wi-Fi weather display project, for example, I broke the shadow box up into sections with a folded piece of corrugated cardboard. Then I taped some pixel strips to the back, shining into each triangle shape. The simplest form of this technique can also achieve a great result, and that's just to line the walls of the box with a single LED strip. Make the inside of the box white so the light can bounce around, and create a cutout face with the design of your choice. If you're looking to smooth out letters on an LED scroller sign, the next obvious choice beyond paper is woven fabric. In the messenger bag display project, I used solid white ripstop nylon to diffuse a large flexible NeoPixel display right up against the surface of the LEDs, otherwise the characters would be blurry. Woven fabrics aren't stretchy, so they're easier to sew and keep flat. If you go shopping for fabric in person, bring a flashlight or use your phone's flashlight to test how different fabrics transmit light. Keep in mind your phone flashlight's a really bright LED. If you're shopping online, look for lightweight synthetic woven fabrics as a starting point. Knit fabric is stretchy. Sweaters are knit, so are t-shirts. Knits can be tough to work with, but are great for diffusing LEDs. Like in the case of the off-white fluffy cable knit sweater, it diffuses an 8x8 neopixel matrix with an added texture that couldn't be imparted any other way. It's probably too thick to read numbers or letters through it, but the soft edges give the snowflakes a very festive quality. Plush toys add a volume of fiber around an LED, usually synthetic fiber fill, and creating some volume can spread out the light and also highlight different parts of the form. Small mason jars often have an interesting texture and can make a great base for a few different diffusion techniques. This is a simple 3D printed lid holding a single LED. Try filling the jar with translucent beads or lining it with a simple piece of printer paper to pick up the glow. You can layer fabrics for a wide variety of diffusion and backlighting effects. The Sparkle Skirt project uses a laser cut micro suede skirt as its base. Light bounces off the back of the overlay and the lining, creating a sophisticated backlight effect. You can also use backlighting and underlighting in many other applications too. In my Internet Valentine project, I glued tiny sequin LEDs to the back of a tissue paper heart, and they reflect off the white card behind to give the heart a red glow. Similarly, the red illuminated button shines up at the tissue paper heart on the remote. Laser cut acrylic affords a few diffusion opportunities, including edge lighting, etching, and coloring in the etching with a marker, like in this Iron Man arc reactor project. Crinoline tubing. I learned this tip from my pal Phil Burgess, who showed me this technique with his Cyber Falls wig project. The crinoline tubing fits great over LED strip that's still inside its silicone sheathing, which gives it some structural support, and catches the light with its cross-woven synthetic fibers. To test out the next few techniques, I built a sample circuit with some neopixel strip and individual pixels on a scrap piece of foam core board. I'll be able to use this sampler in my classroom this fall, and it's also great for showing to costume clients. Ping pong balls are a classic diffusion idea that's not used nearly enough in my opinion. Cut them in half or cut a hole just big enough for your LED. Blast it with a cluster like a neopixel jewel or use a single LED. Also underutilized in the maker scene in my opinion is thermoplastic for diffusing LEDs. This stuff comes in little beads you soak in hot water to make it a pliable dough. It looks great over powerful LEDs, but the more that's on there, the less light will get through since it's pretty opaque once it sets up. Different glues have different light transmission properties, and it's worthwhile to explore what magic you can make with the adhesives you already have access to. For this demonstration, I tried out hot glue, E6000, some silicone substitute, and a common household glue stick. I was surprised to find that the tiny glob of hot glue on just the 50/50 pixel package itself was durable and not easy to peel off. It gives a wide angle and pleasant lens effect and might be my favorite result out of this little testing process. There have also been many 3D printed LED diffusers in my life over the years. It seems unfair to group them into one idea here, but them's the rules. Most have been made from flexible filament with a few notable exceptions, and the Ruse brothers collaborated with me on all of these 3D designs. I hope this video provided you with some sparks of inspiration for creating your own next level LED creations. Let me know about your projects and plans in the comments below. Please give this video a thumbs up and subscribe if you haven't already. I release new videos just about every week about crafts, technology, and my life here in New York City. See you next time. I don't know about you, but I just enjoy making things more when my space is organized. I always get the itch to optimize around back to school time. just as much now as I did when I was a student and not the teacher. So I took on a project to overhaul my small parts drawers and small workbench tool organization. I even ordered a label maker for the occasion. There's just something so satisfying about streamlining things for my future self. I don't know if it's just because I get so annoyed when I can't find something I know I have, but I dread that inefficiency and it takes my head out of my work. But organizing is also a form of procrastination, a way to avoid a looming deadline or ruminate on an idea while executing on something, at least. I installed a magnetic bar meant for kitchen knives and moved my wire rack to its own dedicated wall space. In organizing this part of my workshop, I found a bunch of stuff I didn't remember that I had and got rid of a bunch of trash. Thank you so much for watching. Don't forget to subscribe and give this video a thumbs up if you liked it. See you next time. Welcome back. Today I'm creating ground effect lighting for my scooter using a Bluetooth microcontroller and a dressable LED strip. If you're new to my channel, please subscribe. For this project, I'm recycling 2 bits of pixel strip left over from my old POV bike project tutorial. These are APA 102s or dot stars, but you could totally use NeoPixels for this project. I just happen to have this set of 2 strips wired in parallel, which is perfect for sticking under my scooter. I double-checked and touched up the solder connections, which I made on alternating sides of the strip. It's just cleaner that way. I'm actually using the waterproof alkaline battery holder from the bike project as a project enclosure here. It already has a waterproof switch and it's the right size for a blue fruit feather microcontroller and flat lithium battery. So I removed the metal bits and cut away small sections of the plastic to maximize the interior volume. I did something in this project I don't normally recommend folks do, which is to solder directly to the leads of a lithium battery. And that's because you could short it out and cause a fire. Anyway, I badly wanted to use the switch built into the waterproof battery pack, so I spliced it in. I also removed the original wires and hot glue using a bit of rubbing alcohol. Then I tinned the LED strip wires and fed them through the opening. I soldered up power, ground, and data and clock to 2 different microcontroller pins, and now I'll include a circuit diagram in the Instructable for this project at the link in the description. Once I had the circuit assembled, I went to program it using my Arduino software. I modified a Bluetooth sketch I made for my 2017 LED sign, which used NeoPixels, but the same Bluetooth Arduino compatible feather board. The sketch includes configurable color and a few animation patterns. To prepare the pixel strip for the underside of my scooter, I taped neodymium magnets to each end and used hot glue and more tape to seal up the ends. I've used silicone adhesive to seal up pixel strip before, but it takes 24 hours to dry, and I just wasn't willing to wait this time. I wanted this to be a one-day build so I could go ride. I tried the same treatment with rare earth magnets inside the enclosure, but it just didn't feel sticky enough for the bumpy road, so I found this old Xbee radio antenna magnet and bolted it to the lid. Now all my parts feel super secure, stuck to the steel structure of my scooter. Maybe someday I'll wire these lights into the electrical system of my bike, but for now I'll just remove the circuit for charging. The Arduino Sketch pairs with the Adafruit Bluefruit LE Connect app to use the color picker and the control pad to change between animations. It looks just like my vehicles in GTA Online. Thanks so much for watching. I'd love to hear how you'd make this project your own in the comments below. And don't forget to like this video and subscribe if you haven't already. Welcome back. Today I'm fixing up my vintage neon sign. I got this sign at a stoop sale in my neighborhood in Brooklyn, and for its age it was in great shape, except for its plastic standoff supports, which had become brittle and started to break in several places. And to be honest, I didn't do it any favors by hanging it above the stove in the kitchen. I started out by removing the brittle clips from the mounting plate, which I could easily do with my hands. The supports didn't always come away completely, however. There were still some stumps left over, but I was happy to leave them alone because you can't see them from a distance. If you don't have a backplate to begin with, or yours was broken, you could use a plastic scoring knife to cut down a sheet of black or clear acrylic to just larger than the dimensions of your sign. If you need to cut holes in the plastic for routing wires, do so slowly and with a step drill so as to not crack the plastic. At this point I took the opportunity to clean the sign, using paper towels and an old toothbrush to get into all the spots you can't normally access when the sign is mounted. Removing the dirt buildup can make the sign glow more brightly and evenly too. I got replacement standoff supports from eBay, and my best guess is that they're made from ABS plastic. Any permanent glue that bonds plastics should work fine, but if your sign requires lots of clips, be mindful of the working time for whatever glue you choose. E6000 would work fine, or epoxy with a bit of a longer work time. I used Duco cement because it's what I had on hand. I set the mounting plate on the table and held the neon above it to see where the supports should go. For the most part, I placed them right next to the stubs or on top of the glue spots left over from the previous supports. Once they were all glued down, I double-checked that they'd all line up with the neon before leaving the whole thing to dry. If you didn't want to use a plastic mounting plate, you could attach these standoffs directly to a wall. After the glue fully dried, I carefully fastened all the clips to their corresponding section of sign tube. I used lamp chain to hang the sign from the holes on each end of the mounting plate. You could optionally affix the sign power transformer to the back of the mounting plate with epoxy. My boyfriend and I hung the sign from the ceiling above the kitchen cabinets. The power supply can rest on top of the cabinets, so we didn't see a need to attach it to the back of the sign. The power cable runs down the left edge of the cabinets to a plug on the wall, where I added a switch adapter so I can turn the sign on and off from the location of the outlet. We love our neon sign, and now it looks good as new. Thanks so much for following along. If you liked this video, please give it a thumbs up and subscribe to catch the next one. Welcome! Today I'm building 2 sets of LED eyes that change with a wireless remote. You can find the step-by-step tutorial for this project at the link in the description, including the parts list, circuit diagram, Arduino code, and sewing pattern. Let's go! I made the first version of this project a few years ago for Adafruit, and the basic version is perfect for beginners. The circuit's just 2 NeoPixel jewels and a Gemma microcontroller. But this year, for a DJ and laser performance my boyfriend and I were doing at my hackerspace, I wanted to create twin ghost hoods with colors that changed simultaneously using a single remote. In comes the latching 315 MHz RF receivers and matching remote. These little sets create basically a remote button press, driving the corresponding pin high when the remote signal is detected. That's the nerd alert! This month, a bunch of nerdy creators, including myself, are participating in Nerd Thunder. It's a way for you to find more curious and passionate makers you might not have already known. So check out everybody's links in the description. I started with the NeoPixel part of this circuit, using 6-inch pieces of wire to connect the power, ground, and signal wires. Then another 3 wires connect between the first jewel and the Gemma, which are long enough to reach from my face area to the lapel area, in my case about 16 inches. I like to use thin gauge silicone coated stranded wire, which is flexible like a noodle. I used female header wires to connect to the receiver, which already comes with right angle headers installed. To power each circuit, I'm using a 500 mAh LiPoly battery and some 3D printed holders that get stitched inside the costume. After assembling the 2 circuits, I tested out various LED animations and the remote. As I suspected, running the receivers at 3 volts instead of 5 still works, but the range is somewhat reduced. Onto the sewing portion of this project. I used the same printable pattern I designed the first time around and cut it out of folded white fabric. Since I'm making 2, I doubled the fabric over again so I could cut all the pieces out at once. I ultimately cut out another layer in white cheesecloth to add some more texture. The hood piece and shoulder piece each have shaping seams that need to be closed up first. Then they get sewn together at the neck seam. Next, I stitched a seam along the top of the hood with right sides together. A piece of 19 gauge galvanized steel wire supports the front edge of the hood, so I folded over the fabric and sewed a hem which will serve as a channel for the wire. I cut the face panel from sheer black fabric to roughly matching the shape of the hood opening, then pinned and sewed it in place. The end of the wire should be curled to prevent it from catching on the fabric as it travels through the channel, and then the other end should be curled too, so the wire doesn't stick you while you're wearing it, and to provide an anchor point for hand stitching the wire ends in place. To figure out where to place the LEDs, I found it easiest just to wear it and use a mirror. Then I used matching thread to stitch through the black fabric and circuit board mounting holes. I tack stitched the wires to the inside in a few places and switched to white thread for securing the battery holder, microcontroller board, and wireless receiver. After testing, we discovered the white fabric was letting too much light onto the face, so I cut another layer of just the hood portion of the pattern from some opaque black fabric and lined the hoods. Another key improvement was for visibility. Although you can see reasonably well through the sheer fabric, my boyfriend couldn't read the small text in his Ableton DJ software, so I removed the top section of the sheer fabric in his hood. But from far away and in the dark, you can't really tell the difference. After the Halloween party, we marched in the New York City Halloween parade with my SBA students, who made electronic costumes as a class project. Don't forget there's a step-by-step tutorial for this project on Instructables, and there's a link to that in the description. Thanks for watching. I create videos about technology, crafts, and my life here in New York City. Please give this video a thumbs up and subscribe to catch the next one.
nothing